Perovskite solar cells have the potential to transform solar energy due to their higher efficiency, lighter weight, and easier production compared to traditional silicon panels. They can be synthesized at room temperature using abundant materials, making the process more cost-effective. Researchers at Helmholtz Zentrum Berlin, led by Steve Albrecht, have achieved record efficiencies, particularly with tandem solar cells, which layer perovskite on silicon to reach nearly 30% efficiency. However, perovskite stability remains a challenge, as it degrades quickly when exposed to moisture, heat, and UV radiation, losing 20% efficiency in as little as 6 months. Researchers are exploring encapsulation methods to protect the material, but long-term durability is still in question. Companies like Cells and Oxford PV claim to have developed more stable cells, with Oxford PV achieving 28.6% efficiency. However, verifiable, peer-reviewed data is lacking. Cost competitiveness is another hurdle, as traditional silicon solar power costs about 12 cents per watt. For perovskite to gain market share, it must be cheaper while demonstrating durability. Oxford PV plans to ship tandem modules by mid-2024, potentially leading to solar parks using this technology by 2026 to 2027. While promising, perovskite solar cells face significant challenges regarding stability, cost, and scalability before they can revolutionize the renewable energy industry.